Okay.
Okay, you're good.
Okay. All set. Okay. Well, thank you and Professor Eric and join to our presentation for the faculty and the student grant. Okay. Today we just give it to the center faculty scholarship, report what we finished all this grant. Okay. And we are recorded. And after that, we are sent to share to everybody. Hey, how are you, Professor? And
I'm
you're
doing well.
welcome. You're welcome. Okay, so you ready, Corey?
Yes, yep,
Okay.
I'll present now.
Okay, do it now. Thank you.
Okay, so I just want to introduce myself. I'm Corey Lowe. I am in my senior year. This is my last semester here. And I'm about to graduate soon with this pandemic going on, but all's good so far. But my project is on integrating multiple computerized sensors using a microcontroller displaying LCD. I was able to do this project through the Department of Engineering and Technology and working closely with Dr. Hong Yu, which is my advisor. So first, I want to quickly thank you the annual CFS grant 2020, which supported our curriculum. Below are the 3 different classes that it helped promote. I learned more about microprocessors, device interface design, and this was also included in my senior capstone. I'm going to be talking about smart home systems. A smart home system is a home electronic automation. It's mainly used for homes, industries, businesses, and cars. They're going into more various places, but for now, we'll just focus on that. So they control various settings that include lighting, climate, entertainment systems, and different appliances like all around the house. So in 2016, Zion's Market Home Research Group did a study on the smart home global market, which was valued at $55 billion at the time. And its projected growth in 2025 would be $170 billion. So as you can see, it's a growing industry and economy. So this smart home residence uses Bluetooth, it uses internet, uses Wi-Fi connected systems, starting off with different appliances such as like thermostat. It uses those 3 concepts and eventually goes into your smartphone, which can then be applied and used by the user. So this smart home system offers security, comfort, convenience, energy efficiency to its owners, often letting them control these different devices through their smartphones. It provides like safety, accessibility, energy efficiency, and cost effectiveness and convenience. So on to the next slide. So my project, as you can see on the right-hand side, it'll be controlling these different types of applications throughout homes and businesses. So I was able to do this research through the CFS grant and further my studies in the undergraduate studies of electronics engineering. This project will be combining and learning different practical practices in real life. But one of the main reasons why I focused on this project was for the solar decathlon, the collegiate solar decathlon project, where this electronic application will be used. It'll be focused on controlling multiple different devices using microcontrollers, microprocessors with human communication outputs, and eventually programming will be installed into it from both hardware and software side using different libraries, which can then easily be read by users, owners of all sorts. So the purpose of my project was because of these emergences of these smart home electronics. They're being implemented in everyday households, schools, you're starting to see them more often. Different companies such as like Apple, Amazon, I'm sure you've heard of Nest, they're making all these new different types of applications for electronic control devices. On the left-hand side, you can see some of the uses for it, like such as light control, window control, LED monitoring, and thermostat, which is one of the most popular ones. So these sensors will include smoke detectors, temperature regulators, of all sorts that can inform people about safety levels of controlled gas and climate conditions within cars, homes, and businesses. So don't be fooled by all this data. This was just a flow chart, as you can see in the middle column. It's describing how it goes from electronic hardware, which you can analogize it as a thermostat, like an electronic thermostat, where it starts off with temperature sensor, humidity sensor, able to display data through an LCD shields. It eventually moves on to embedded systems, which includes the microprocessors and microcontrollers. If you're following the flow system down below, it eventually leads down to the interfaces, which include a physical and a virtual interface. The physical interface includes a PC monitor and the LCD. The virtual interface includes a program that I use in my project called Sketch, which utilizes C++ computer science language. Eventually, it moves down to machine learning down below. This is where artificial intelligence comes in, using data it collects from, if you move down to the modeling data system. The modeling data system is where it collects all of its data that's collected, such as like temperature, humidity, gas controlled devices, all sorts. So machine learning, what it does is it manipulates and uses these programs in order to talk with the virtual interface and the physical interfacing, and eventually moves back up the line to a smart home, via smart home, through electronic hardware. So these devices are used controlled through a controlled microcomputer that communicates with different programs, different electronic devices, that eventually be programmed to talk with its user and owner. This device can be altered and freely used by different inputs and tasks for autonomous systems and faster and more efficient machines. So inside my project, on the left-hand side, you don't have to read it all. It's just a more in-depth description of the flowchart you've seen previously in the other slide, explaining how it collects data through the individual electronic component part of the temperature sensor, sends the data to the microprocessor. The microprocessor sends its data to the modeling database system, and which eventually gets transferred and conjugated back into the microprocessor and back up the line to an electronic controlled device, which is the LCD. So a series of sensors are integrated into a board, translate the LCD. All at the same time, all this data will be saved on a database, an iCloud, and eventually be used by artificial intelligence, machine learning, and deep learning machines to predict different systems, system environments like warnings and alerts. Down below it is just a description of the different individual components that I use, just like terminals, bus ports, and whatnot. So when I talk about the code, software, and the analysis of the project, this is where a bulk of my time was used. I used a program that utilizes C++ programming. On the right-hand side, you can see these different instructions being written, and at the top where you can see #include. Those three different libraries are included, which are the three different types of components I'm currently using, which is the temperature sensor, the LCD, which is displaying numbers, collection of datas, and the third component is the humidity sensor. So, I'm using the Arduino software using a microprocessor. So it's an Arduino microprocessor that makes all this coding easier. When using two different devices, it's a lot easier, but when using three different devices, that's where the troubles start coming in. So when you start adding more devices together, there's more translational issues, more integrational issues, and as you keep adding them together, things start getting mixed up. So this is where my part in coding comes in. So an example of the code that's included is that the Arduino software, when it's collecting data through the temperature sensor, it doesn't actually read Fahrenheit or Celsius. It reads the voltages coming through the device, through the temperature device, and to the Arduino, and then it gets converted into Fahrenheit and Celsius through an algorithm, a pre-made algorithm in the code. Once this is all done, it can eventually be displayed and read. So you'll be able to see like temperature, you'll be able to see humidity, you'll be able to see different parts of what it has to offer. So on the left-hand bottom, you can quickly see the different internal components. The red large side is the red on top is the LCD. Underneath it, you can see multiple resistors. You can see different wires leading to different S buses, ports, and terminals. And all this is internally put into the right-hand corner, which is the eventual project of what I'm trying to make. So with this process, it'll be put into a microprocessor, integrated into electronic measurement devices, collected. And on the right-hand side, as we said before, all this will be wrapped in a 3D case. So Fitchburg State has a 3D printer where I was able to use this as an opportunity to learn about 3D printing using Autodesk software. And once it's put in its case after you create it, it's ready for modeling and real applicational use. So I'm implementing this project into the Solar Decathlon project, which is a zero carbon footprint house that college students are trying to make at the moment. Greenhouse gases, these effects results in climate change and global warming. So we're trying to limit that by creating these greenhouses, which include the Solar Decathlon project. So this device will bring leading edges in controlled energy and efficient environment. Regulation and control as main key factors towards decreasing carbon footprint and eliminating any wasted power. Eventually, this results in clean, producible solar energy. So my future works of this project. So right now, we have those 3 different devices. Like I said, the temperature sensor, the humidity sensor, and the controller or microprocessor. Eventually, I want to be able to use more measuring devices such as air, gas measurements, light, pollution, and sound sensors. Eventually, this will lead to a total control over the environment and system. So the next step towards this zero carbon footprint house is creating a LabVIEW interface. This will be creating the integration between human and machine. All this information that it collects, all the electronic information that it collects, I want to be able to store it on a cloud and eventually be used for later projects down the road, ways to increase and improve efficiency within houses. I want to provide ease and convenience and later use for homes and organizations. These are a couple of references that I made. This is the project video. It's taking a little long to load. Yep. So I just want to quickly introduce this project to you guys. As you can see, the sensors, the white sensor down at the bottom is the humidity sensor, and on the other side of it is the temperature sensor, which can read outside environmental things such as like Fahrenheit degrees, and eventually more components will be used and put into this project, and eventually it'll be ready for a real applicational use.
That was great.
So,
Corey,
Yeah.
in the future, do you envision like in different rooms of the house there would be like a sensor for different things that could one sensor pick up multiple things and
Yes.
there'd be a limit on how many things they could pick up?
Yeah, so there'll be no limit. It's just going to be a little bit harder as you add more devices into one.
Mm-hmm.
But eventually it should be able to control different devices throughout a house or organization or business.
Mm-hmm. Do you think there'd be something in every room would have to be like could it be a small sensor like on the wall or something, or what do you envision?
Yeah, it could be something as small as a simple sensor on a room, but you might not need like multiple thermostats or in different rooms. You could put different sensors into each room if you'd like, but it'd be probably put in like the main a main living room or any place like that, bedrooms. I can check on like pets and children, other people. So.
Mm-hmm. That's really interesting. And are your
questions?
Yes.
Okay. So this one's can we put on the smartphone, right?
Mm-hmm. Yes. So it'll eventually be integrated into a smartphone where the user will have access and control to it. They'll have access and control to almost everything that the sensor pretty much reigns over. So.
Yeah, that's we next the project.
Yes.
Try to put all the data to the smartphone. That's way to try to do that. I want to send the proposal. So that's the next time we'll do that. Yeah. So second, this one we always post on the YouTube now, so everybody can later maybe link to the website. They all click. They say, oh, we have a Pittsburgh student did a very good project over there.
Yep. So that's mainly my project. We're working on future works that I hope that other students below me that we're talking to right now can eventually grab the project and improve upon it, grab different sensors, put it into it, make it usable by a phone so that everyone can use it, and just adding more components to it, creating softwares for it, using the data, manipulating the data, creating statistics for the data, and just creating like lower bounds and higher bounds with it. So.
Yeah, and also we can just like Professor Eric, just the answer to you, because you say put a very small sensor. Yes, we can. We suppose put this one on the window. You know why? Because sometime in the morning, no enough oxygen, so they will send the data. So we have found it outside, inside. We can compare. That's what we're supposed to. You're right. Exactly. We put a small one. We can compare it.
That's interesting.
So eventually it can regulate like different air temperatures, different gases being controlled, different systems, energies coming in and out. So.
So you don't want to go outside to measure the oxygen inside the oxygen. You don't do that. You just keep your smartphone and say outside, inside. Oh, we should open the window. Like that. That's I say that. That's for the solar, the cursoring, the project in our we have a department, we have a that project for a long time. I say, we can inside, we don't know enough oxygen, how to do that. So we can put the smartphone, we can compare it. Oh my God, please open the window. Like that. I just say that this way.
Yes, so that concludes my project. If you guys have any more questions or so.
Well, I had a question. Your modeling database, what does it use as source information? Is it just using the information that comes in through the sensor, or are you using other databases of previously measured information?
So are you talking more about like here, let me just present this real quick.
Because you talked about on the bottom of the when you had your on slide 7, I think it was. I don't know. Yeah, no, the modeling. Yeah, slide 6. You're right.
Mm-hmm.
You mentioned the modeling databases here that your machine learning algorithms are using.
Yes.
Is the data that you're using in there just the information from that individual's home that they've gathered from those sensors, or are you looking at data beyond that particular environment?
So for the individual person, it will have data just for that person. Is that what you're trying to get at, or?
Yeah.
Yeah, and then for like if you are like a CEO of a company, you can get the data. The data will be sent from the company to your company, the smart home system company to your company, and you can learn how to like manage that and equip it better. Is that your question? Sorry.
Well, yeah, but I think I'm just remembering the Nest controversy over privacy issues of data. So
Yes. So this data, I'm not controlling too much of this data. So right now, this is just for individual use. So you should be the only one to be able to see this.
Mm-hmm.
Yep.
And then you said like artificial intelligence would be able to figure out if there's like a variation or sudden change in certain levels, and then a warning could be sent to the homeowner is the goal, right?
Yes. So I'm hoping that there will be like a lower bounds and an upper bounds, and if it hits these bounds, it will tell its user and inform its user like, hey, you've hit like the limit on this, like make sure to go down a little more, or eventually it should be able to change it by itself.
Right. Oh, that's great. Well, thanks. This was really a really interesting project. It's really doing great work. It's great to see.
We just
Yeah,
started. We just started. So next step we have a first term, second term, third term.
Yeah.
So we'll do that. Second term, I suppose, for the smartphone, so everybody can get the data. And the third phone look like a machine learning and give a warning, look like that. The data we can go to where save data. We can compare the history data. We can say what's problem. That's for third terms. We just started first term.
Yeah,
I think it's
absolutely.
interesting too, because you finished your presentation kind of talking about controlling our own environment. And I think it's interesting to consider, well, what kinds of sensors would you want to include, or what components do you think are most helpful or interesting to control? So humidity is a big one for me.
Yeah, most definitely, though.
but it does make you wonder what other people would think is very valuable, or what might be underrepresented in the kinds of controls people are developing when you're thinking about whether it's safety or comfort or health inside of your own home.
Yeah, I mean that's a huge one as well. So I was reading a subject that Dr. Hong Yu was creating. I heard that he created a sort of pollution sensor. So for like a scientist or something trying to discover more about global warming or pollution or something like that, they could place these different sensors in like different cities, and they can measure the pollution output and all these different things.
Yeah.
Yes, that's a very, very good contributions. That's right. And also we do this one again. We do this one just training our undergraduate student how to do research, how to practice. That's we're supposed to do this way. But next step, we'll have more steps. As I say that. Yeah, exactly. Because we're undergraduate student, you cannot, look like they become a PhD or master, But they already did. Very good. They say, I put the community. Next time I put the pollutions, all these things. But you know that how to integrate, that's very good. How to work, that's good.
Yeah.
So in
Well, it's a
future,
great way to learn.
yeah, exactly. That's
It's
where our
exciting to see.
purpose. That's
Yeah.
our purpose. Our purpose is that student learn it and how to integrate all these sensors. That's what we try to do. That's the purpose, I think, do this project.
Great.
Yeah, so hopefully we can continue doing this project later in the coming years, and maybe I can come back to this and think like, oh, hey, look, this is a project that I started. It's really awesome, and it's helping other people learn and grow as well. So
Yeah.
I
Yeah.
already send the 3 this year. I already did. First one for the professor, what's his name, Alberto Provost. He sent the one that we applied the special project, project. So
Yeah.
I sent that one. I sent that one is for we call the sensor system platform. That means that all put inside. That's I send the one for that one. Another one that's for about the smartphone. That's for undergraduate student to do smartphone. So that one for the department, that's 2, and the 3 for my personal research. As I did 3 this semester. That's a lot of job I did.
Well, that's great research you're doing. It's excellent to see. Yeah. Right.
Okay,
Yeah.
Professor, you have any questions?
Any last questions?
No, I think all set. I think it's really an exciting project. It's really great to see what you've done. I look forward to hearing future projects.
Right.
Very good.
Yeah.
Next step, we'll go to online. Go to on smartphone. That's it. Okay, APP. Everybody use APP.
Yeah.
Do that.
Well, thank you both. This was great. Thank you very much.
Okay.
Yeah.
Thank you for coming, and thank you for giving me this opportunity to work more at home with this project. So
again, thank you. You give us the this grant. Give us the proper chance to do all these things. Thank you.
Great.
Okay.
Take care. Thanks a lot.
All right.
Okay.
Thank you for coming.
Okay. Okay. See you. Okay.
Bye-bye.
Bye.
Thanks.
Be safe. Okay. Be safe. Okay. Bye. Bye.